All right, last synthesis strategy. So this one extending a carbon chain. Okay, let's go over the old stuff first. Okay, this is how we extend the carbon chain. So the first one that you learn from alkyne, alkylation of alkyne. Okay, next one we have a Grignard reagent attack on an aldehyde ketone. Now you can see that the new incoming carbon, the alkyl group, is on the same position with the functional group, same position on carbon 1. Okay, if you do the same reaction but switch the aldehyde ketone off, and you get use the epoxide. This guy attack, pop the ring open, the incoming alkyl group and the OH, the functional group, are on two adjacent carbon. So you can control the region where the reaction happened, the functional group would go to. Okay, relatively new from a previous chapter, we have the Vedic reaction. Okay, you can control E and Z. All right, from the older one, so the chapter before that, we have Friedel-Crafts acylation. Okay, all this allow you to extend the carbon chain in any situation, from an alkyne, from an aldehyde ketone, from an epoxide, aldehyde ketone, leave an alkene to this one, and this one from the benzene ring. You can extend the carbon chain in pretty much any functional group that you have. Okay, all right, let's take a look at the new one. Yeah, something going to be new, something going to be old. All right, let's take a look. All right, on the left side, this one we extend the carbon chain using the nucleophilic acid substitution. Grignard attack twice, one leave first, you get a ketone, attack one more time, you get these two alkyl groups. Okay, we have Gilman's reagent. This one attack one time, you get a ketone, and this one react with the Grignard, react with the cyanyl group. Okay, all right, but this way to extend the carbon chain, you can see that the functional group OH, the oxygen stay on the same carbon. This carbon is that carbon, this carbon is that carbon, and this carbon is that carbon. Right? Functional group remain the same carbon, the same position. The other way I'm going to show you, the functional group move a little, okay, by one carbon. Here's how it works. We start with an alkyl bromide, add a cyanyl group, bam, functional group move to the next carbon. Right? Or we make this guy Grignard reagent first, attack the carbon dioxide, and that functional group move from here to that carbon, the new carbon. Okay, so you have to look out where the functional group goes. Are you adding carbon? Are you losing carbon? Okay, you have to be aware of those two. Well, let's take a look at the examples then. Okay.